All right, guys. So Unit 2 is done. Again, we looked at functions, and most importantly, we looked at functions on a graph. So we're going to take that a little deeper today, and for this unit, and we're going to start to look at some different graphical characteristics of a line. So we're going to start pretty basic, and then work our way up to kind of the big picture. So today, we're going to start with Unit 3. And Unit 3 is linear relationships. Okay, so with linear relationships, okay, we're talking about how the variables relate to one another. That's the relationships part. And a linear equation, which is just the equation of a line. So we're going to break down that equation. We're going to look at different parts of the equation, and then we're going to actually put that into process, looking at the numbers versus the graph, etc. Okay, so today's topic is slope. Okay, so when we talk about slope, right, we're hopefully kind of aware of the word, and most of us would attribute that to a hill or something slanted, maybe a ramp. And that's ultimately what we're going to be uh, investigating is the steepness of the graph, how it's changing from one variable to another, from one x value to another. So over the domain, how the graph is increasing or decreasing or neither. So just to define slope for future purposes, right? Slope is a ratio. Okay, so it's always going to be in a fraction form, so it's going to have a numerator and a denominator. A ratio that relates one variable to another. Okay, so very simple though, that this part right here is the important part, right? The fractional aspect, right? We want a fraction when we see slope. That's what's going to allow us, right, to read into it without actually having to do any math, really. You're just simply looking at it, and there it is. So for this unit, right, we are talking about linear slope. And with linear slope, that's the slope of a line. More importantly, it is a straight line. Okay, so it's the slope of a straight line. Now, because it's a straight line, that is implying for us that it is constant. All right, so a little bit more about slope as a ratio, right? So slope ratio, okay? Again, it is A over B. I'm going to go 2 lines on this one. But more importantly, we're going to think of that as rise over run. Okay, so when we think about our x's and y's, our rise, okay, that is the up and down, right? So the up and down portion of it versus our run, which is the left and right. So we're going to be looking at the change in y over the change in x. All right, and that can be abbreviated with the delta symbol. Looks like a little triangle there. It's just a Greek term to mean change. So that is change in y over change in x, just shorthand. Okay. Now, as far as the ratio goes, we always put it into simplest form. Well, I'm not sure that's how you spell simplest. Simplest. That looks better. All right. So always in simplest form. Okay, so example there, real easy, right? If you have something like 6 over 2, we would divide that, right, and say 3. We would not leave it as 6 over 2, but we would know as a ratio, 3 is equal to 3 over 1. Okay, so our rise would be 3, our run would be 1. All right. Now, lastly, it is always defined as the variable m. Okay, m. The variable for slope is m. Now, there are 4 types of slope. Okay, so just to kind of investigate that, I'm going to draw 4 basic graphs so that we can sketch a different line on each one and get a feeling for the 4 types. All right, so our first type of slope is going to go from low left to high right. And if you can imagine, okay, a little guy on the graph, right? He's walking up that line. Now, we're always going to read it left to right, okay? So 4 types of slope, red, left, whoops, to right. All right, red, left to right. So he's walking up the graph. He's heading in this direction. We're going to think of that as uphill. And so that's just how we think of it, right? It's going uphill, it's going up, and therefore we say that is positive. Now, once we get into a little bit further, not only is it positive, it has a numerical value. Okay, so we're going to be attributing an actual number, but it's going to be a positive number. Okay, the next one would be a downhill, right? It's headed down. So our guy is sliding down, right? So he is downhill. And those are going to be negative. Now, the vast majority of our slopes will be one of these 2, okay? It's going to be positive or negative, but there are some special cases for us, all right? So special case number 1, our guy is simply walking along a flat surface. And so this is a horizontal line, and we simply say that is no slope, or it has a value of 0. Okay, so this is the one we can determine an actual value for ahead of time. And then lastly, okay, we have what would be seen as a vertical line. Okay, so nothing for our little guy to hang on to. He is falling and falling fast, right? He's just sliding right down the side. So this is vertical. And this has a very special name, okay? It is undefined. Okay, undefined. And that's very important, okay? And you'll see why here in a second once we start calculating the slope. But we can't confuse these 2. A lot of times, right, this is the main mistake I get, is that when we see a vertical line, we like to say, well, it has no slope because it goes straight up and down. But really mathematically, it has one name and it is undefined. So zero slope means a horizontal or flat line versus the undefined slope, which is vertical. And those are very different mathematically. So want to pay attention to that going forward. But the uphill or downhill, the positive or negative, those are very easy to determine just by sight alone. Okay. So the first thing we're going to do today is we're going to talk about how to determine slope from a graph. Okay. So to determine slope from a graph. It's very simple, guys. Okay. There are two steps. Okay. First, we start from the leftmost point. Okay, so start from the leftmost point. And then from there, it's very simple. You're going to count up, which would be positive, or down, which would be negative. And that is going to be our numerator. Okay, and then next, we're going to count right. And that becomes our denominator. And then all we simply do after that is simplify if possible. Okay? So start from the leftmost point, count up or down, and then right, and simplify. Okay? So I'm just going to go through a couple of examples for us so we can kind of get the hang of it today. And then we'll leave it at that, and we'll explore a little bit more tomorrow regarding slope on a graph. Okay? All right, so let's get our examples out. Go the other way with it. Okay, so in looking at this graph, okay, very simply, right, I can see just at first glance, this is a positive slope. It's definitely going uphill for me. So starting on the leftmost point, that is this point here. Okay, I'm very simply going to count. Now I'm counting up. So 1, 2, 3, 4, 5. So I went up 5. Now I'm going to put a +5, but it's not necessary, right? If it's positive, we know it's positive unless it has a negative. And then I'm going to count over to the right. So that's 1. So 5 over 1. So my slope for this graph would simply be 5. Okay? And it's that easy. We're simply counting from one to the other. All right. Now this one again, right? We are looking to count left to right. Now we always kind of form this right triangle as we count, but it's a good idea to mark them down if you have them physically, because sometimes we can get lost in counting squares. But knowing that I'm going to count from one to the other, I know I want to hit this point right here. Okay, that's going to be kind of the intersection of my up and down and left to right. Now, starting from the leftmost point, again, right, start here. That's the starting point for us, leftmost point. So I'm going to count 1, 2, 3, 4, 5, 6, 7. So that went down 7. Okay, so down 7. I'm going to use a -7. Okay, and then I'm going to go to the right. 1, 2, 3, 4, 5, 6, 7, 8. So I went over 8. Now that bottom number is always positive. It's the top number that's going to be either negative or positive. And so in this case, I can't simplify that. So my slope is -7/8. Okay, so we can always, right, try to simplify it a little bit. All right, so if we can, looking at this one, all right, this one is definitely, right, definitely negative, and we're going to start from the left and count till we get to a nice little right angle point, which is right there, right? So down 1, 2, 3, 4. So down 4. And then I'm going to put that over, right? 1, 2, 3, 4, 5, 6. All right, so negative 4/6. Now I know I can simplify that to negative 2/3, which means, right, these are not the best 2 points to illustrate this slope. There's actually a good point right there, because if I had gone down 2 and over 3, I hit directly on the line again. Okay, so in simplifying it, you're going to get the closest 2 points together when you look at it. So let's look at our special cases. And this one doesn't have any, so I'm just going to add some dots to it so that we have something to count to and from to illustrate, right? So for this one, right, we should notice it is flat, right? It's a horizontal line, which means that, right, we already know what the value is, okay? But why is the value what it is, right? So I already know that the value is 0. But why, right? So let's look at that. All right, so remember, we count from the left to the right. So in this one, do we go up or down? And the answer is no, right? We don't move at all. So that's a 0. Okay, we did not go up, we did not go down. But we could say we went to the right 4 places. So 0/4. And on our calculator, okay, if we were to go to our calculator and type that in, okay, 0/4, and hit divide, we would get 0. Okay. It's okay. We're taking 0 things, dividing it into 4 groups. Each group gets 0. All right. But if we look at another special case, right, of our vertical line, and again, just going to put some dots on here so we can illustrate what's going on. We don't have a leftmost or a rightmost, but we could count from one to the other. So vertically, right, I'm going up 4 from one to the other, so up 4, but I did not move left or right. Okay. And many of us have asked Siri to divide by 0, and she gives you an explanation. But basically here we have 4 things that we are asked then to divide into 0 groups. And we just can't do that, right? The 4 things can never be dispersed. So we're kind of stuck. And that's why this is mathematically impossible, right? We cannot give these 4 things to 0 groups and have any kind of numerical result. And so when you go into your calculator to do this, I'm going to jump over there real quick for us. You'll see, right? So I've got my calculator here. I'm simply going to put 4 divided by 0. And it tells you, hey, that's undefined. That is a mathematical anomaly, and we cannot do that. Okay, so even your calculator tells you what the name of this is. So it's very important if we were to actually calculate each one of these values that we look and see how we can get this to be reduced, actually do the division. We don't want decimals though. Okay, so going back to our negative 7/8, right? If we were to put that into our calculator, okay, so you see we've got our calculator. I'm going to do negative 7 divided by 8. Well, I've got to get rid of the old one. All right, negative 7 divided by 8. And we get this negative 0.875. Which is all fine, you know, if some of us prefer to do operations with a decimal, I can understand that. But when you look at, right, the decimal value here, there's no way to count, right, up and over with this number, right? Technically, it's a fraction of 875 over 1,000. And then we simplify that to 7/8, but you're adding more work. If you just leave it as a fraction, and you can see the negative is there in the middle, we'll always place that with the top number, so just kind of push it up and over. We want to know what the fraction is because the numerator tells us how to move, right? It tells us go down 7 from that point and then to the right 8 spaces. Okay, so down 7 to the right, 8 spaces. And that's what makes it so easy when you leave it into fraction form. Okay, so don't change these into decimals. We definitely want fractions. That's about as far as we're going to take it today because there's really no more. We could do more examples, but it's the same every time, right? Start from the left, count up or down, and then to the right. And you come up with a fraction that can be simplified sometimes. And then that's our answer. That's our slope. Okay. So that's going to do it for today, guys. Be looking for a little bit more in depth tomorrow, and we'll see you then. Thanks, guys.